All right, we are going to be studying 3.1, 3.2, and 3.3. So we're going to just work on some of the basics of inequalities. We're then going to solve one-steppers by addition and subtraction, and then we're going to use multiplication and division to solve inequalities. All right, so example 1, write an inequality to represent the verbal expression. Okay, so all real numbers, x. So anytime they give you all real numbers, you don't have to worry about that. They're just telling you to use the letter x, which will represent our real number system. So x less than or equal to -7. So on this guy here, you're just going to write down exactly what it says. X is less than or equal, remember the less than looks like an L, -7. That's all you're writing there. Okay, so now this one says 6 less than a number, k, so we're using k, is greater than 13. So here's often a problem area right here. How do I know if I put an inequality there or an inequality here? Okay, there is a difference. So if I'm looking at this guy right here, that word is, okay, really important, that word is telling you that's where your inequality symbol goes. So on this first part right here where it says 6 less than a number k, remember less than just means subtraction, but when we see that than, it means we've got to flip the order. So this is actually saying k minus 6 is greater than, okay, so that is means I have to put the inequality symbol there, 13. All right, next one. The sum of t and 7 is less than 3. So sum means add, so I'm adding t and 7 is less than, again, you see that word is showing up, -3. So that is tells you where the inequality is going to go, just like up here on the first one, or the second one, okay? All right, so now, a solution to an inequality is any number that makes the inequality true, okay? So the question is, which ones of these work? Which one are answers? Now, there's not really a shortcut to this. You're going to just plug them all in and see what works and what doesn't. So I'm going to start with the -1. So 13 minus 7 times -1 is less than or equal to -3. So now just solve. 13, -7 times -1 is +7, less than or equal to -3. So is 20 less than or equal to -3? The answer is no. Okay, so that's not an answer. So that guy's out. So now you go to 0. 13 minus 7 times 0 is less than or equal to -3. Okay, again, anytime you multiply something by 0, it's just 0. So you have 13 is less than or equal to -3. Does that work? No. Okay, remember, alligators got to eat the bigger number. So 0's out. 13 minus 7 times 1 is less than or equal to -3. So we get 13 minus 7, which is 6. So is 6 less than or equal to -3? The answer is no there. So then I'm going to my last one here. 13 minus 7 times 3 is less than or equal to -3. So 13 minus 21 would be -7. So now is -7 less than or equal to -3? Yes, it is. So this right here is your answer. Now, when you write your answer out, though, make sure that you use a set bracket. So you see how they give you set brackets here? Okay, if you start with set brackets, you finish with a set bracket. So do set bracket, put in what answer worked, so 3 worked, and close it off. Okay. All right, example 3, graphing on a number line. All right, so keep in mind that if we don't have an equal sign, it means we're going to have an open circle. Okay, so I'm just going to kind of number, I'm going to put -4, -3, -5. Make sure your number line is correct. Don't do it backwards. Okay. All right, so -4, open circle, means I have an open circle. And then it shows you which way to shade. Just make an arrow. So in this case, I'm going to shade to the right because that's which way my arrow is pointing. Okay, so now an open circle, we got to go a little more in depth into this. An open circle means that this is not part of your solution. Okay, so -4 is not an answer. -3 is an answer. -2 is an answer, etc. These are all answers. Anything not shaded is not an answer. And not shaded includes this guy right here because he's not filled in. Okay, so an open circle is not part of the solution. Okay. All right, so let's go to the next one. Now on this one, first rule of thumb is your variable has to be out front before you start graphing. So you are going to flip this whole thing around and send it in the other direction. So you're going to say, instead of 2 is less than or equal to W, you're going to say 2 is greater than or equal, sorry, W is greater than or equal to 2. So again, I'm going to put 2 in the middle there, put down a couple numbers, okay? Now in this case, because there's an equal sign on it, it is a closed circle. Okay, so a closed circle would look like this. It's a filled-in circle. And again, you're looking at the arrow. The arrow is going this way, so you're right here. Which way is that arrow pointing? He's pointing to the right, so you go to the right. Okay, so now a closed circle means it's part of the solution. Okay, so 2 is an answer, 3 is an answer, 4 is an answer. Not 1, not 0, because there's no shading there. Okay. All right, next thing you're going to do is just going to ask you to now write an inequality to represent what's on the graph here. So pick any variable you want. I'm going to use x. Okay, and then you're kind of looking here. Is it opened or closed? Closed has an equal sign on it. Which way is it shading? So since it's shading to the right, that's which way your arrow points. And then you're starting at -1. So this graph would say that x is greater than or equal to -1. Okay, so now on this one, we've got an open circle. So again, any variable you want. Open means no equal sign. It's shading down this way, so it's going to the less than, so it looks like an L, and then 4 is where it starts. Okay, now, something we're getting ready to talk about, so we'll talk about it now, is you have to understand that this is a set of numbers. Okay, so there's going to be a whole lot of answers that are going to work. In fact, infinitely many answers that are going to work because this number line keeps going. That's what this arrow means. Okay, so when we are technically writing out our answer right here, we should be putting in what's called set builder notation. So set builder is just saying we have a huge set of numbers, and here's how you finish it off. You're going to put a line X and a set bracket. Okay, and how you would read this is all values of x such that, that's not what that line, this line right here means. So all values of x such that x is less than 4 is how you would read that. Okay, so again, all values of x such that x is less than 4. Okay, all right, let's go to the next page. All right, and the last one for lesson 3.1 is write an inequality to describe the situation. Be sure to find a variable. So in this case, you are going to be looking at this picture. This is all we've got. We've got trail rides, and they're starting at 1999. Okay, so I'm going to put, like, let me zoom in here a little bit. I'm going to put T equals amount of trail ride, or amount for a trail ride. Okay, and then if I'm looking at this, it's starting at 1999, which means it's just going to go bigger. So trail rides, 1999, and I want it to go bigger than 1999. So 1999 is going to be my smallest number. So if it's your smallest number, alligator eats the other side. Now, could it equal exactly 1999? Yes. Okay, so again, starting at would be your low point, and it should go up from there. Okay, let's try it again. A restaurant can seat at most 170 people. All right, so I'm going to put P for number of people. Okay, so they can seat at most. So I got P, I got 172. At most means I can't go above it. So alligator eats the bigger number. 172 is your bigger number. Now, could they equal exactly 172? Yes, they could. Okay, and then again, if we do ask you to put this in set builder notation, you're just going to put a line P out front and a set bracket. Okay. All right, please ignore this. This is for if we've done this in class, so go ahead and just ignore this, all right? And we're going to move into lesson 3.2 and 3.3 now. Okay, so it says solve and graph, write your final solution in set builder notation. So that's what we were just doing right here, set builder notation. All right, so now we're going to look at lesson 3.2 and 3.3. We're going to solve, we're going to graph, and then we're going to write our answer in set builder notation. So let's look at this first one here. So again, this is just solving kind of like a basic equation, except for it's going to be an inequality. So you're still going to undo things. So by add 15 over to the other side, so you get x, keep your sign, greater than 3. So now when you do your set builder, line x, set bracket. Okay, now it did ask us to graph, so we're going to go ahead and make our number line here and just put a couple of numbers in, one on either side. Okay, so now on this guy, this would be an open circle because there's no equal sign, and you should be shading to the right. Okay, so on B, we're going to add 3 over. So we get 13 is greater than or equal to x. Now again, your variable needs to be out front, not only for graphing, but also to write it in set builder notation. So you're always going to put the variable out front, okay? Again, line x for your set bracket, or sorry, for your set builder notation, and then graph 13, 12, 14, so closed circle, so fill it in, and you're shading to the left on this one. Okay. All right, so now on this guy, we're going to multiply both sides by 3. So multiply this by 3 and have it cancel. Multiply this side by 3. So x is less than negative 6. Again, set builder notation. And I'm going to go ahead and start skipping the graphing just for right now, just to save some time. Okay? All right, so let's go to the next one here. All right, so now on this guy, we're going to multiply by the reciprocal. So we're going to multiply by negative 4/3 on both sides. Now, there is a rule here. So the 4's and the 3's will cancel, but anytime you multiply or divide by a negative number, so in this case we're multiplying by negative 4/3, your inequality symbol has to change direction. So it's going to become from greater than or equal to less than or equal to. The 3's will cancel, and we'll have a negative 4 here. So now you're going to go ahead and write set builder notation, so line W, and then close that off. All right, so looking at E here, we're going to divide both sides by negative 7. So those cancel. So we have negative 7. We flip our inequality symbol because we divided by a negative y. Now, once again, you're going to have to rewrite this because you need your variable out front for set builder notation. So y is greater than negative 7. Then put line y and a set bracket. Okay, so again, you read this as all values of y such that y is greater than negative 7. Okay? All right, and again, ignore that stop and let's move off to the third page. All right, so on this guy here, they're asking us to write an inequality and solve it, and then write your final solution in set builder notation. Now, I went ahead and gave you this table up here at top just to help you with your wording in case you don't know all your words yet, okay? So this is just kind of a little table here to help you do your symbols. Okay, so write an inequality and solve. A number increased by 6 is less than, okay? So now again, we see that is less than. So again, we see that is there, and that's important because that tells us where our inequality is going to go. So a number increased by 6, so x plus 6, is less than negative 4. All right, so now solve it, subtract 6 over. So x is less than negative 10. Line x and a set bracket. Okay. All right, the product of 5 and a number, so product means to multiply, so 5x is at least, and okay, so you can either come up here and you can look at this guy right here and see at least is greater than or equal, okay? Or another way to do this is if you're not very good at like memorizing all those, put 25 on this side, okay? So is at least 25, so I think about can I go bigger than 25? If it's at least 25, the answer is yes. It can go bigger than 25. So again, alligator eats the bigger side. This side would have to be your smallest. So now you divide by 5 and get x is greater than or equal to 5. Again, set brackets. Okay? All right. And real world problems. Define a variable, write an inequality. Notice how the directions are telling you now to write inequality. So it used to say equation, then proportion, now it's saying inequality. Solve and then write your sentence, your solution in a complete sentence. A hard drive on your computer has a capacity of 120 gigabytes. You have used 85 gigabytes. You want to save some home videos to your hard drive. What are the possible sizes of the home video collection you can save? Okay, so we're going to start by defining our variable. So let's put H. I'm going to put H for size of home videos. Okay. All right. And then it says that we have a capacity of 120. So now if I got a total of 120, I can't go over 120. So alligator eats the 120 and then put an equal sign there. All right. So now H plus, what have we already used up? We've already used up the 85. Okay. So now you can solve this. Another way you could have done this is you could have went ahead and kind of kept it like this and then put 120 minus 85. Those would both be acceptable answers. And it's the same thing because you're just going to subtract 85 from both sides. Okay? So it doesn't really matter which one of these you write, you're going to get full credit. Okay? Just as long as that alligator is pointing, just make sure that alligator is pointing towards the biggest number. Okay? In this case. So let's go ahead and subtract that. So we're going to get H is less than or equal to 35. Okay. So now when we write our sentences change just a little because we have to include the inequality. We can't just say that it is 35. Okay. So we could write, I could save up to 35, what was this in, gigabytes. How about gigabytes of home videos. Good. Okay, now, important part here to note is, notice how I'm saying up to 35. You've got to have something that talks about that inequality symbol. Okay, so at least 35, or sorry, at most, at least, things like that. Those are the wordings that you can use in there, okay? So up to, and another option there would be at most. Whoops, wrong one. At most would work here as well, okay? All right, let's try one more here. A student club planned to buy food for a soup kitchen. A case of vegetables costs $10.68. The club can spend at most $50 for this project. How many cases can the club buy? All right, so there's my inequality, or my definition of variable here. I'm going to put C for number of cases. Okay, and they said it was $10.68 a case. So $10.68 a case. And then it says I have at most $50 to spend. Okay, so if I put 50 here, if I have at most 50, that means 50 is my biggest number, so alligator eats your bigger number there. Now, I could spend exactly 50. All right, so let's go ahead and we're going to divide by 10.68. So we get C is less than or equal to 4.68. Okay, so now the question is, though, how many cases? All right, well, they're not going to actually be able to buy a 5th case. They only have enough money for 4 cases. And so you have to address that in your answer when you write your sentence. So they could buy up to, or you could say like at most, 4 cases. Okay, again, make sure you're including that inequality word, something that's telling us that this is an inequality. Okay, and that concludes the notes for 3.1, 3.2, and 3.3.